Okay, today we're continuing on with Module 5, Lesson 15, and your learning goal is the same as yesterday. This is such an important skill to be able to take what you learned about area and apply it to real-world contexts, to word problems, that we're going to spend 2 days practicing this skill. So you can see that your learning goal, just like yesterday, is I can solve real-world problems about area. And one such real-world problem is your problem of the day. It says the length of a flower bed, remember that's where people plant flowers, okay? The length is 4 times as long as its width. If its width is 3/8 of a meter, what is the area? So the question is asking us to find the area, and we know that the length is 4 times as long as the width. So is it longer or is it wider? Which one's bigger, the length or the width? Length. How much bigger is it? 4 times. Now if I know that the width is 3/8 of a meter, that means here's the flower bed. If the shorter part is 3/8 of a meter, how can I find out how long it is? It's 4 times the width. So what do I need to do? Jaden? You got it. 3/8 times 4. And since 4 is a whole number, I'm going to put it as 4/1. Now we can multiply. I can see that I have similar factors. I can divide 3/8 by 4/4, and I can divide 4/1 over 4/4. Yes? So, well, the 4 becomes a 1, and the 8 becomes a 2. Do you agree? Okay, so what's 3 times 1 then?
3.
And what's 2 times 1?
2.
3/2 is the same as 1.5 meters. That means the length is 1.5 meters, and the width is 3/8 of a meter. Now, it's asking us to find the area, so how do I find the area? I can multiply the length times the width. The length times the width. So it would be 1.5 times 3/8. Now, remember, there are 2 different ways we can multiply mixed numbers. What's one way? Using improper fractions. Let's do that first. 1.5 is the same as 3/2 times 3/8. Now I can multiply. What's 3 times 3?
9.
What's 2 times 8?
16.
So the answer is 9/16. But what's the square meters? Good. I know it's squared units because I'm working with area. And I know it's meters because in the problem, it tells me the length and the width are using meters. Now, if I really wanted to be sure that I was correct, what's the second way I could solve it? Using area model. Good. So I'm going to do that because I want to be sure. Okay. So I know that over here I have 1 and 1/2, right? And over here I have 3/8. How do I find the area of this first part? How do I find the area of that first part? Emily? 3/8 times 1. Very nice. Which is? Very good. Now, let's find the area of this second part. What's the length I just drew in blue?
3/8.
What about that part?
1/2.
So how do I find the area of that entire thing? 3/8 times 1/2. What's 3 times 1?
3.
What's 8 times 2?
16.
Okay, so then to find the total area of the whole thing, I have to add 3/8 plus 3/16. 3/8 plus 3/16. But I need common denominators, right?
Yeah.
What would my common denominator be?
16.
Okay, 3/8 is the same as how many 16ths?
16.
Okay, if I have 6 16ths and I add 3 more 16ths, how many do I get?
9. 16.
Do you see how I got the same answer? Now I'm confident. Given this problem in my notebook, I would draw it like this. I would draw a big rectangle that shows the entire wall. I would show that from here to here is 52 1/2 feet. I would show that from here to here is 33 feet. Okay, and then I would draw 4 rectangles like this and label it A, B, C, and D. So you can see that it doesn't match up exactly with the picture, but it's enough to give me some information. The next thing I would write down in my notebook is this information. Window A, and you could label it right on your picture, or you could write it separately. Window A is 6 1/4 feet by 5 3/4 feet. Window B is 3 1/8 feet by 4 feet. Window C is 9.5 feet squared. So what does that tell you? That's already the area. And door D is 4 feet by 8 feet. Now, if we're going to paint this wall, do I have to paint the windows or the doors? No, so I'm going to find all this area that's not the windows or the doors. So let's talk about the steps of the problem first. What do I need to do first? Go ahead and talk to your partner. So the first step I'm going to need to do is find the area of the entire wall, including like all the windows, right? So how would I do that? I need to multiply 52.5 by 33. Do you agree? Yes?
Yeah.
This is the entire thing. Very good. Once you find each partial product using the area model, I could just add up 1,716 plus 16.5, which is?
1,732.5.
Okay, very good. Square feet. That's the area of the entire wall. Do we need to paint the entire wall?
No.
We're not going to need to paint the windows or the doors, right? So what do I need to, can I figure out how big each window or each door is? What do I need to do? Find the area and then subtract it from this total, okay? Let's do it step by step. One tip I have for you is to be super clear with your work. For example, if you're finding the area of window A, label it so that later when you come back, you can know what your work was. Also, that way if you make some mistakes, your teacher can see, oh, they did A right, but not B, so I can give you partial credit. If it's all jumbled up, I can't even tell what's what, right? So if you're very clear with your work, then I can give you partial credit. What are the dimensions of window A? You should have written it down. Haley?
6 1/4 times 5.
6 1/4 times?
Times 5
5
and 3/4.
3/4. Okay. This time, let's do improper fractions. Why not? Are the numbers too big? Okay. I personally prefer area model, but let's try improper fractions. Let's challenge ourselves. 6 1/4 is the same as how many fourths? 25 fourths. Okay. 5 3/4 is the same as how many fourths? Okay, so this makes us need to do 25 times 23. I actually don't prefer that. Do you prefer that? Maybe. But I prefer an area model because the numbers won't be as big. So then I can have 6 1/4, and then I can have 5 3/4. And I will say, looking at your area models on the work you guys have been doing, they've been pretty accurate. The part you guys have been messing up on is not finding each individual area. It's the adding part at the end. Okay. To find this area, we do 6 times 5, which is? Thank you. To do this part, we do 5 times 1/4, which is? 1 1/4. Very nice. To find this part, we do 6 times 3/4, which is? 18 over 4, which is? 4 and 2/4, or 4 and 1/2. To do this part, we do 1/4 times 3/4, which is 3/16. So to find the total area of window A, we do 30 plus 1 1/4 plus 4 1/2 plus 3/16. So we have 30 plus 1 1/4 plus 4 1/2 plus 3/16. Let's add all the whole numbers first. 30 plus 1 plus 4. What is that? Okay. Then I have plus 1/4 plus 1/2 plus 3/16. What's my common denominator going to be? 3/16 or 16. Good. 1/4 is the same as how many 16ths? Thank you. 1/2 is the same as how many 16ths? Okay. 3/16 is the same as how many 16ths?
3/16.
Okay, if I have 4 16ths and I add 8 more, how many do I have?
12.
If I add 3 more, how many do I have?
15.
15 16ths. So I have to add that to my whole number part. So my answer is 35 and 15 16ths. That's the window A. Okay, of course is it feet? Square feet? Yes?
Yeah.
Okay. So now that we know the area for all 4 of those cutouts, what do we have to do? We have to subtract all those from our total. What was our total? 1.5 square feet. Okay, so we can either add up everything that we need to subtract, or we can subtract one at a time. Which one do you guys want to do? Let's add everything up and then subtract it all at once.